Have you ever just wanted your own Jarvis? Or maybe your own Siri or Alexa that does exactly what you want it to? Well, guess what? Today, we're going to do just that. We're going to build our own personal voice assistant from the ground up, and we're using one of the best tools for the job, Python.
You know, it really does feel like magic, doesn't it? You say something out loud, and a second later, this voice just responds. But behind that incredibly simple back and forth, there's a really fascinating chain of technology all working together perfectly. So in this explainer, we're going to demystify all of that. We're going to pull back the curtain and show you the actual blueprint. We'll break down exactly how these systems think, step by step, so you can see the engineering behind it all, and yeah, even build one yourself. Okay, before we even think about writing a single line of code, we have to get our heads around the core logic. Think of this as the brain and the nervous system of our assistant. So what actually happens from the moment you speak a command to the moment it gets carried out? This right here, this is our roadmap. It all kicks off with your voice, which gets turned into text. But here's the really clever part. The system then has to figure out what you mean, not just what you said. From there, it spots the command, does the task, and finally, talks back. Every single one of these steps is its own little puzzle we need to solve. Now, to bring that roadmap to life, we're going to need the right tools. And the great news is, the Python community is amazing and has already built some incredible libraries that do all the heavy lifting for us. So let's take a look at the essential building blocks in our toolkit. Each one of these plays a super specific role, almost like different parts of a body. You've got PyAudio, which is the microphone, just capturing the sound. Then speech recognition acts as the ears, turning that sound into text. Then comes the brain, that's spaCy or NLTK, which figures out what you actually want. And finally, PyTTSX3 is the voice that lets it talk back. Put them all together and you've got a complete system. All right, theory's over. We've got our blueprint, we've got our tools. It's time to roll up our sleeves and actually start building. We're going to put together the core of our assistant in 4 really clear, manageable steps. Let's do this. First things first, our assistant needs to be able to hear us. I mean, it's a voice assistant, right? So this very first step is all about getting the microphone turned on and recording the raw audio of our command. Without this, nothing else can happen. And to make that happen, we're going to use the PyAudio library. You can think of it as the bridge between the physical world of sound waves and the digital world of our code. It's the piece that's always listening, waiting for that command to start recording. Okay, so we've captured the audio, but now we've got a new problem. A raw sound file is basically just digital noise to our program. We need to translate it into something the computer can actually understand and work with. And this is where the first bit of real magic happens. The speech recognition library takes that raw audio file and, using some seriously powerful engines behind the scenes, it transcribes it into a simple text string. So the sound of you saying, "What time is it?" becomes the actual letters WHAT and so on. Pretty cool, right? All right, so now we have the text, but just knowing the words isn't enough, is it? Our assistant needs to understand the meaning, the intent behind those words. And this is where natural language processing, or NLP, comes in. This is the thinking part. I mean, think about it. You might say, "Hey, could you do me a favor and tell me what time it is?" The only important part of that whole sentence is get time. NLP libraries like spaCy are designed to tuck through all the conversational fluff and pull out the key action. This is how our assistant goes from just hearing words to actually understanding what you want. So let's recap. We've captured the sound, we've turned it into text, and we've figured out what the user wants. The only thing left to do is, well, do it. This last core step is where the assistant actually performs the action you asked for. And this all boils down to some pretty simple but really powerful logic. If the command is X, then do Y. So, if our NLP step figures out the intent is get_time, our code calls a function to check the computer's clock. If the intent was search, it kicks open a web browser. And just like that, our assistant is actually functional. So our assistant can now hear, understand, and act. That's huge. But for that really satisfying interactive experience, it needs to be able to talk back to us. This is the final piece of the puzzle, the part that really makes it feel alive. Hey, remember that PyTTSX3 library from our toolkit earlier? Well, this is its time to shine. It literally stands for Python Text-to-Speech, and its job is super simple but also super important. You give it any text string like, "The current time is 10:30 a.m., and it says it out loud. And that's it. We've closed the loop. Okay, we've built a solid foundation here. But this technology is moving at an absolutely incredible pace. So where does it all go from here? What are the big challenges developers are trying to solve right now, and what kind of stuff can we expect to see in the very near future? This slide shows a really fascinating contrast, right? On the one side, you have the challenges of today, like just being able to understand someone in a noisy coffee shop. But on the other side, you see the future. Assistants that can have truly natural conversations, that can predict what you need before you ask, and can seamlessly control every smart device in your home. So there you have it. That's the fundamental blueprint for creating your very own voice assistant. We've gone all the way from spoken words to digital actions. The tools are out there. The logic is clear. So really, the only question left is the most exciting one. Now that you know how, what's the very first thing you're going to build?